Hey guys, welcome back. This is Professor Hank, and in this video we're going to continue our discussion on the LISP programming language by talking about lists. Now, lists in LISP are kind of what gave LISP its name, right? Because LISP, is short for the list processing language, right? And in traditional LISP, lists were the fundamental data structure, right? So later versions of Lisp added other things like trees and arrays and vectors, but way back when in the beginning it was just lists, right? So a list in Lisp is implemented in memory using a version of a simple linked list, and you're going to see that it's pretty easy to get started with these things and to manipulate it. You just have to use the appropriate functions, and I'm going to also show you some useful predicates, right? So let's go ahead and get started. Okay, so a list can be made up of anything in Lisp, right? It can be made up of numbers, all different types of atoms, other lists, right? Whatever you can think of, you can put inside of a list, right? And so maybe the easiest way to create one is to use the list function, right? So I'll go ahead and show you how to do that, right? So if I want to create a list function, and then everything after the list function, all the arguments are just going to be whatever you want to put inside that list, right? So I could specify that I want A, B, C, 1, 2, and 3 to be part of my list, right? And if I do that, then you're going to see that the list is going to get created, right? Okay. Now, compiles just fine, but what was there to show you? Nothing really, right? So let's go ahead and assign this, or we'll just pass it straight to the right function. How about that? So that way we can see the results of that list getting created, right? So there you go. So you see the ABC 1, 2, 3, that created my list. Now, if I wanted to actually be able to manipulate it in some way, then it might be useful to actually assign it to a variable, right? So I'll name this variable, dog or something, right? It doesn't matter. I can name it whatever I want. And I'll do a similar kind of thing here. Oops. Okay, and then I'll write out the dog. Okay, so should see that list get created a couple times. There we go. Okay, and then you can also create a list. You don't even necessarily need to use the list function. I could do something like this. I could say, well, set q cat, and then I can create a list, right, by just using the apostrophe here and then typing out what I actually want the list to look like, right? And so then I could write out that list. Okay, so let's run it one more time, right? So there's my new list. So 3 different lists here, made a couple different ways, right? So, now lists can have a mix of whatever you want to put inside them. So how about we create another list? We'll call this one rat, and I'll put inside of this list other lists. Right. So we'll see 4DE, fine. Okay, and then I'll write out the rat. Right. Okay, so let's go ahead and run that. Okay, so you can see lots of different ways that we can create lists. Okay, so how can we manipulate lists, right? So let me just create a really simple non-nested list, right? So I'll create a variable, I'll just call it cat, and I'll use the list function to create the list, and I'll just assign it, just some simple characters here, just so we have something to display, okay, or to work with, I should say. And let's run it. So there's our list. Now I want to go through these different functions for manipulating, right? So we've got car, cutter, cons, list. Well, I already showed you list, right? We use that to create functions. So I suppose I could get rid of this guy from here. But append, last, member, and reverse, right? So how about we go through and play around with these guys in no particular order. So the car function here, right? If I pass to the car function a list, right? So for example, the list that is defined with cat, right? And I print that thing out. So what car does is it peels off a copy of the first item in the list, right? So you can see that the result of car cat was that I got a member of the list, not a new list, just the first member of the list, right? So that got me the A from the cat list, right? So that's how you can retrieve the first item, right? You could think of this almost like pop for a stack, right? Or DQ for a queue. The thing is, though, is that it's non-destructive, right? So you'll see if I print out cat again, you'll see that the original list hasn't changed, right? So it just peels off the first item in the list, but doesn't remove it, right? It just returns a copy of it. Okay, so that's what car does. Now, what about cutter, CDR, right? So what CDR does is that returns a list that is everything but the first item in the list, right? So let me just show you. So cutter cat, right? And this guy also is non-destructive, right? So the original list is going to remain unchanged. Okay, so we can see right here, B, C, D, E, F, that's the remaining portion of the list, right? So that's line 18, the results of line 18. And you can see that the original list that I assigned to cat has remained unchanged. Okay, so let's talk about cons. And the cons function can be used to create a new list that is the combination of two existing things, right? So let me give you an example here. So if I wanted to combine the list A, B, C, D, E, F, if I wanted to get that cat list, and then I wanted to make that list be the first item in a new list, and I wanted to put, say, G as a second item in that new list, then I could do something like this, right? So I could say, I can take cons, and I would take the name of the first item that I want to have in the list. In this case, it's itself an entire list. And then I would then use cons again and specify the name of the thing that I want to become the second part of the list, and then I would add nil here, right? So what this is going to do is this is going to create a new list where the cat list is the first element, or the first item, and then the G here is the second item, right? So I'll just go ahead and print that and show you what it looks like. Okay, so there you go on your bottom line. So you've got a new list, A, B, C, D, E, F. List is the first item, and then G is the second item. Now, this is kind of a convoluted way of making new lists. It would be a lot easier just to do this with the list function. So if we were to do something like this, say list cat g, right? And you can see that's going to be a lot easier to do. So let me go ahead and run this. So see, we get the exact same result, and we don't have this nested recursive kind of a structure going on here. But without that list function, and you wanted to create a new list, say, containing ABC, you'd have to do something along the lines of this. You'd say cons of A, and then you'd say cons of B, and then you'd say, I mean, it just gets gross. Then you'd say cons of C, and then you'd have nil there, and then you'd close this whole thing off, and then I'll just pass this straight to the print function so you can see what it would look like. Right, so it's kind of gross creating new lists that way. There you can see the ABC, right? So list function is definitely a lot easier. The main use for cons is really to create these dot pair structures within Lisp, but cons works this way as well. Okay, so let me show you how the append function works. The append function, you're gonna type that append up there, and then you can string together a bunch of lists and as arguments, and the result will be a new giant list, right? So I could do something like this. I could say, well, we'll take A and B, and then we'll append to that C and D, and then we'll append to that E, and then we'll append to that F, G, H, right? And I'll just send that new list straight to the print function so you can see what it would look like. And I'll go ahead and run this thing here, and you can see, oh, I forgot my single quotes here, right? Because remember, Lisp tries to evaluate even items in the list if you want to create a new list with them, right? So let me go ahead and fix that, run it again. And so now you can see there's our A, B, C, D, E, F, G, H, right? So that created a brand new list for me that is concatenating all of these other lists. Okay, so you could imagine that it would be really easy to combine car, cutter, append in different combinations to get you, whatever list that you need. Okay, so another example of this, let's go ahead and take our cat list, and then we'll append a cat G. Right? And then I'll just print it straight out so you can see what it looks like. Okay, so you can see the last line there. There's the result of us appending G to our cat list. Now that creates a brand new list, right? If I just print cat out again, you'll see that the original list that I assigned to cat unchanged. Okay, so what about last? Okay, well, last is kind of like the opposite of car, right? So how about we just print out the last car, and we'll see, or not car, sorry, cat, our cat list, and we'll see what we get. Okay, so you can see there's a F right now. Last is not exactly like car, because remember what car does is it returns a copy of the first element of the list, right? So what last does here is it returns a list that contains the last item in the list. Okay, if I wanted to do something more like with what car was doing, but for the end of the list, I could combine car and last cat, right? And so what's going to happen? Well, remember, car just peels off a copy of the first item in the list, right? So now you can see there's just a regular old F, right? So car last cat is kind of like the opposite of car cat, right? You just got to combine those two things together to be able to extract the last item from an existing list. Okay, so let's take a look at the member function. Member function is going to take two arguments, and the second argument is going to be a list, and then the first argument, if it is a member of the list specified in the second argument, then this is going to create a new list, or return a new list, that is everything after the first argument, right? So let's give this a try with cat. So we'll do something like this, right? So member, and then let's say that I'm going to look for D in this second list. In the second list, I have that assigned to a variable named cat, right? So I'll just print out the results of it, and we'll see what we have, right? So there's the last line, D, E, F, right? Why did we get that? Well, because there's D, right? There's the first argument, and so we got the D, E, F out of this thing. Now, again, non-destructive. If I print cat out again afterwards, you're going to see that the original list is still unchanged. And keep in mind, these functions I'm showing you, what they're doing is they're returning a list, or in the case of car, a single value, which you can then use later on for later processing. So, for example, what if I wanted to pull out that DEF and use it for something else? Maybe I'll call it dog, and I'll say, well, remember D cat, right? And then I can print out the dog, right? And let's see what that looks like, right? So you can see with the output, right? I printed out cat on line 38. There's the original list, unchanged, right? And then I created a new list that is made up of everything from D through the end that belongs to cat. And so I called that list dog, and then I printed out the dog, right? So the last function that I want to show you here, and then I'll show you a couple of predicates and how those work, is going to be reverse, right? So what does reverse do? Well, all reverse does is gives you a new list that's in the reverse order. So I'll just go ahead and print the reverse of cat to the screen for you, and show you what that looks like. Okay, so there you go, FED-CBA. Now, if I wanted to pull off a copy of the F item, another way that I could have done it, right? I showed you combining car and last. Well, I could combine car and reverse, right? And have the same effect, right? So there you go. Okay, so the last thing I want to show you are a few useful predicates that could be helpful when dealing with lists. Those will be null, listp, and equal. Predicate is like a Boolean function, right? What you do with predicates is you feed them some arguments, and they return true or nil, t or nil, right? So t is true, nil is equivalent to null or false in Lisp, right? So first one that I'll show you is null, and null takes as an argument, can take as an argument a list, right? So I'll give it cat, and then I'll just print out what it returned, right? So what that's gonna, well, you'll see, right? It's gonna show us nil because why? Cat is not empty, right? There's actually something in that list, right? But if instead, I gave it a list, and this is a list right here with nothing in it, then that's going to evaluate to true, right? Because this list is null. There's nothing in it, right? So I'll leave both versions up here so you can compare them side by side, right? Cat, and then have another one print null, A, B, C, right? So that null function can be useful for the base case of recursive functions. If you're recursively going through a list and passing back smaller and smaller versions of the list until eventually there's nothing left inside the list, well, then null could be useful for getting you out. Okay, now of your recursion. Now listp is going to return true if the argument that you pass it is actually a list, right? So cat is a list, so it's going to return T, right? So you're going to see that here in a second. So there you go. Now, what if I were to pass it something that wasn't a list, right? Like maybe 8, right? What's going to happen? Right, nil. Why? Because 8's not a list, right? Okay, and then finally equals, or equal. Now the equal predicate is what you'd want to use if you want to see if two lists are structurally the same, right? So this is different than trying to determine if 7 and 4 are equal or not, right? I mean, this is, lists themselves in Lisp are objects, and so a simple arithmetic equals isn't going to do it, right? So we need to have something a little more involved. So that's what the equal function does. So we'll take 2 arguments, right? And so maybe I've got the list ABC and the list ABC, right? So this is going to evaluate the true, which you'll see when I print it out, because the lists are the same, right? So there's your T for true. If they were different, right? So let's say we make this just AB, right? Well, then that's going to return nil. And you know, I put in some lists here using this apostrophe operator here, but you know, it's going to work the same for variables, right? So if I say cat and then I have a list with just one item in it, you know, that's going to return nil because you know, cat and the list A don't have the same, right? Okay, so I think that that's everything that I wanted to show you in terms of the basics of lists, how you can create them, how you can manipulate them using card cutter, cons, append, last, member, reverse, and a few useful predicates to help you evaluate the lists, whether they're empty with null, whether it's a list at all with listp, and then whether or not the lists themselves are equal. Okay, so that's going to bring this video to a close. If you felt that the video was useful, please consider giving the video a thumbs up, and if you thought that the video sucked, well, then you've got that thumbs down button as an option as well. If you'd like to see more videos, if you're interested in more content from the channel, feel free to hit that subscribe button. And as usual, if you're a student of mine and you have further questions, feel free to drop me an email or to stop by my office hours. Okay, thanks for watching, and we'll see you next time.